Going over lesson 7.2, understanding theoretical probability. So yesterday we talked about likelihood and outcomes, and today we're actually going to be talking about the theoretical probability of things happening. So let's start with some definitions. So the first definition we got is that of theoretical probability. So theoretical probability is the expected outcome of an event. This is what we expect to happen based off our probability of each event. And then an event is a single outcome or a group of outcomes. So theoretical probability is kind of like what we were doing in class yesterday. It's where we assume what is going to happen, but we don't actually carry out the event ourselves. So if we're assuming that when we flip a coin, that the theoretical probability of landing on heads would be 1 out of 2, but we don't know if that's actually what's going to happen, right? Because you might flip a coin twice and get heads twice in a row. So that would mean that we didn't get that tails, that heads 1/2 of the time, but the theoretical probability is still 1 out of 2. All right, so our key concept. Our key concept is we can determine the theoretical probability of an event written as P of event if you know all the possible outcomes and they are equally likely. So this is our first formula for this chapter here. So we got the probability of an event is equal to the number of favorable outcomes divided by the total number of possible outcomes. So this is going to be a definition you guys really need to get down in your notes. We're going to be using it a lot. All right, so what does it mean that there is an equal theoretical probability of each outcome? Do the following have equal theoretical probabilities? So let's just think about this for a second. So what does equal theoretical probability mean? Well, it means that the probability of each event, the theoretical probability of each event is going to be equal to one another. So let's start off by looking at flipping a coin. Well, what's the probability of heads? Well, our total number of outcomes is 2. And our number of favorable outcomes, or the number of times we're going to land on heads, would be 1, right? So our theoretical probability would be 1 out of 2. Now for tails, we're going to do the same thing. So it would be our number of total outcomes, which is 2, and our number of favorable outcomes, which is 1. So that means that the probability of heads and the probability of tails are both equal to 1/2. So this one would indeed be true. They have equal theoretical probability. Now, how about rolling a dice? Well, if we're rolling a dice, we would have 6 numbers, right? So our total events would be equal to 6. And then each number appears once, so each event would have a probability of 1/6, because we have a 1 in 6 chance of getting a 1, a 1 in 6 chance of getting a 2, a 1 in 6 chance of getting a 3, so on and so forth. So rolling a dice also has equal theoretical probability. Well, how about pulling marbles from a bag? Well, this one's a little bit different here, because it depends, right? Depends on how many marbles are in the bag, what type of bag we're talking about here. There's a lot of factors that go into it. For example, if we have a bag with 5 marbles in it and they're all 5 different colors, then we would have a 1 in 5 chance of pulling out each color, right? But say we have a bag with 4 red marbles and 1 green marble in it, then we would have a 1 in 5 chance of pulling out a green marble and a 4 in 5 chance of pulling out a red marble. So this one right here, this does not have equal theoretical probability all the time. And then spinning a spinner with 8 different equal sides, this one would also be check, right? Because we would have a 1 in 8 chance of each side landing. Each side landing up, as long as these are 8 different equal sides. All right, let's get into an example here. So Monique rolls a 6-sided number cube labeled 1 to 6, and we want to find the probability of rolling a 4. All right, well, let's start off with our favorable outcome. Our favorable outcome is rolling a 4, right? And how many times does a 4 appear on a number cube or on a dice? It appear 1 time, right? And the total number of outcomes we'd have, that's the total number of outcomes we have possible. So there's 6 sides on a number cube, so we would have a 1 in 6 chance of rolling a 4. So how about the probability of rolling an odd number? Well, let's find out what our odd numbers are. So we have a 1, a 3, and a 5. Everything else would be even, right? 2, 4, 6, all even. So that means our probability of rolling an odd number would be 3, because these are our 3 favorable outcomes, over 6, or our total outcomes possible. Or we could write this as 1/2. We'll reduce it there. Now, if Monique rolls the number cube 12 times, how many times would she expect to get a number greater than 4 to be rolled? All right, well, how often would we expect a number greater than 4 to be rolled just in a normal scenario? Well, what numbers are greater than 4? We have 5 and 6, right? Or our probability of greater than 4, we could write 2 out of 6, or 1/3. So if we want to think about this, how many times we do it out of 12 times, how many you'd expect that? We would want to multiply our 1/3 times 12. So when we do that, we'll cancel our 3's right here and get a 4 up top. And we would expect to get a number greater than 4 times if we roll it 12 times. But again, that's just a theoretical probability there. All right, so here's our next problem. In a game, the probability of guessing which of 5 boxes contains a tennis ball is 1 in 5. About how many winners would be expected if 60 contestants play the game? Let y'all pause this and think about it for a second. All right, so our probability, our theoretical probability is 1 out of 5, and we're playing it 60 times, or there's 60 contestants. So I'm going to multiply this 1/5 times 60 over 1. Do a little simplifying here, so that 5 is going to cancel to a 1. That 60 will become a 12, and we will get 12 over 1, or 12 winners. So what did we do there? Well, we had our theoretical probability, which was 1/5, and we multiplied it by our number of contestants, or our number of trials, which was 60. So we did 1/5 times 60, and we found out we had 12 winners. So let's go over our conclusion here. So today we talked about theoretical probability, and theoretical probability is what we expect the outcome to be after conducting our trials. And then an event is an outcome or a grouping of outcomes, right? And then we determine the probability of an event. We did a few examples with that. And then we discovered some less than, equal, or greater than in probabilities. Basically, what was the chance of something happening? All right, guys. Hope you're able to answer the questions after this. Feel free to contact me with any questions you guys